Hi, welcome to Real Learning Center. So, what is real learning? Let us understand this with an example. Let us say there is a question called what is photosynthesis? So, there is actually an explanation of photosynthesis in a textbook. If you go and see in a textbook, you can see a neat explanation of photosynthesis. And teachers teach them, and children write about them, and they also make notes about a question and an answer way. What is photosynthesis? And there is an answer. Now, what are you expected to do as a child? A child is actually supposed to understand the question or understand what is written in the textbook. Photosynthesis. To understand this simple one page of a photosynthesis, you need to basically know grammar. Okay. If you don't know grammar, you can't understand. So you need to know some grammar. And that grammar will lead you to understand. Many children actually face problem at this level itself. And even if you know grammar, it is important to understand the semantics. So what is semantics? Semantics is all about the meaning. So you have to know the meanings of the words. You also have to know the connection between the words. So what is the meaning of this happens because of this? Or what is the meaning of this happens after this? These are all different things. And if it is written in a book saying that photosynthesis happens in the night with the help of sunlight, a child should be saying that, no, no, I don't believe this because there is no sun in the night. So all this common sense and the meaning put together we call semantics. A child should have an understanding of semantics to be able to understand what is written. This basic understanding. Okay, the next level only is what we call biology because photosynthesis is coming under biology. So in biology, you need to understand to the extent that the plants do photosynthesis and you have a leaf which participates. All the leaves participate in photosynthesis. There are tiny, tiny cells within these leaves. And these cells internally have something called as chloroplast. And this chloroplast is the real hero here. He makes food. Food means sugar. How does he make sugar? So he simply takes sunlight. By using sunlight, he actually puts in, he takes water from the ground and he takes carbon dioxide from the air and put them together using sunlight and makes sugar. And you get sugar. And that sugar later becomes carbohydrate or protein, all that. So that is basically the food. That's how a photosynthesis happens. If you know this much, and it gives us, let us say, oxygen in the process. If you know this much, you know the photosynthesis from biology perspective. Now that's not the end of it, but that is exactly what is required from the from basically syllabus point of view. Now, if somebody understands up to this much about photosynthesis, it is a good beginning, a great job done. But this is an average, okay? But typically, if you look at some students, who are not really satisfied at this level, they want to go one step further. So what do? They will ask questions like, for example, what do you mean by taking water and taking carbon dioxide and put them together and make sugar? Can I take water in a beaker and put some carbon dioxide and stir it and then put it in sunlight? Can I get what we call sugar? Will it become sweeter? So such children actually try to investigate more, and they end up into a new branch, which is basically chemistry. Okay, they understand the equations, they understand the how to write those equations and how many molecules are there, what happens, what is an exothermic reaction, what is an endothermic reaction. So the whole of chemistry sits in your head, and in that head of which containing chemistry, if photosynthesis goes and sits, suddenly your understanding deepens one level more. So at biology, you have an understanding, a level of understanding. At chemistry, you have deepened your understanding. So that is where many children actually reach. And even brighter children, even children who are interested more to do more and more research and thinking. So such children actually ask even more difficult questions, more involved questions. Like for example, a child can ask, what is this energy all about? You're saying that from sun we are getting energy, and is it pouring energy into this? So that is the question you ask. And then suddenly you start exploring. See, for example, there's something called as potential energy. You have springs, and the springs, when they're pushed, they actually hold some energy. When you release, the energy comes out. So this is a kind of energy. So energy is like this form. It is not like you can pour energy or store energy in any other way. So, but where is the spring here in photosynthesis? So it is not the spring. It is the kind of force. Now it is we are just establishing here a certain kind of force is required to store energy. Now in atoms there are forces. So these forces are called electromagnetic forces. And like protons and neutrons getting attracted, protons and protons getting repelled, molecules forming and bond forming, all that requires certain forces. And those forces actually are responsible for storing energy. And that part of that part of discipline is physics. And you learn physics and you learn math. You know what is differentiation, integration, all that. Start doing. So those are required to learn that. So you learn a lot of physics, and out of that physics, the chemistry of photosynthesis goes and sits, and suddenly your photosynthesis knowledge even more deepens. So when that happens, actually, we say that there is an understanding that is reached, and a very deep understanding that is reached in our head. Now we have a very nice, deep understanding of what photosynthesis is in our head. And this whole part is what we call assimilation of knowledge. So the assimilation of knowledge gets deeper and deeper into head and basically connects with your understanding of physics, connects with your understanding of chemistry and biology, and to some extent you start even asking questions like, if plants are actually giving out oxygen, and it helps us if they give out oxygen, so why can't we have more plants? So you get into environment, ecology, you get into social aspects and everything. So at this point, if you are asked a question, what is photosynthesis? Now, whole of this understanding in your head creates the answer. Okay. So that is basically what we call reconstruction of the answer. And when that happens, you actually, when you write the answer, what is photosynthesis? Now that has full meaning. So the answer has value. It's a golden answer because you know you are writing it from so many different levels. So this is basically what happens when you start learning well. So is that really happens in our real life now today? Does it happen around us? Now we have seen to the extent that in the exams, you know, people actually simply take a small sheet of paper and copy directly the answer. So this we call actually cheating. People try to get marks, 90 marks or 80 marks by cheating. So that is not our real learning. However, more predominant is not that cheating. There are a lot of people who do honest work. They don't cheat. So they actually do one level more. So what do? They actually learn the paragraphs as it is. Learn actually means by heart or mug up as it is and store it in the head. And then they go and reproduce that in the exam. So we call that rote learning. And this is the predominant way of learning. In most cases, this happens. The next thing that happens that is basically expected, at least that is expected, is at least you learn up to biology. Okay, this is the expectation from the textbook writer. This is the expectation from the syllabus, the guy who formed the syllabus. So this is a typical understanding. So typical expected learning at an average level is this. At least go up to biology and then come back. So you can score 95 even here, but your 95 is better better high quality 95 marks. Now I'm telling you that if you actually take the path which is deeper, this cannot be taken by everybody. Some people take this path. So if you take this path, that is what we call actually real learning or a deep learning. So real learning is about actually connecting all these things. So why is such a real learning required? Why does one need to do that? Why can't we simply do rote learning and get marks? You can, but you can get marks in your board exams and in your school exams. But if you are if you have learned it like real learning, if you have done real learning, you can actually do well in competitive exams, in in your higher education, in your job, and ultimately in your life. So that is the advantage of real learning. So what is real learning? Real learning is all about looking around in your world, seeing everything from past to future, seeing everything from natural to man-made, and trying to understand them deeply, and connect them in your head. And so that's what we call real learning. Understanding the world around us, natural or man-made, and connecting them in our head is real learning. So happy real learning. Thank you.